Inside a huge spinning disk of dust, Earth began as a pint-sized planetary pup, warmed by the sun. But she couldn't stay small. For millions of years, meteors crashed into Earth. Each one made her grow bigger and hotter. She began to melt and turn herself inside out over and over. Her sizzling red lava spewed into vast glowing seas. Meteors finally stopped bombing Earth. She cooled and her crust hardened. Steamy clouds cooled too and condensed into droplets of water. It was a glorious moment when the great rain began. It poured for millions of years until oceans covered your Earth. Molten red rock pushed up through the ocean floor. The volcano. A volcano is an opening of the Earth's crust that allows hot, molten, melted rock to flow through it. Volcanoes are found where the Earth's plates are pulled apart or pushed together. The cone of the volcano is made of ash, lava, and dust that is emitted by the volcano. It often grows until it is the size of a mountain. The crater is in the middle of the cone. A volcanic crater is a rough circle at the top of a volcano where the eruption takes place. Many times the crater is located at the top of a mountain. The moon and many other planets have volcanic craters. Magma is melted rock found below the Earth's surface. It gathers in magma chambers, which become extremely hot. When the pressure becomes too great, the magma chamber erupts into a volcano. The magma flows into the volcano through past volcano or sometimes out the sides of volcanoes. Lava is magma that erupts onto Earth's surface. Its temperature can range from 1,300 degrees Fahrenheit all the way up to 2,200 degrees. It can flow for great distances before cooling and solidifying. Ash consists of very fine rocks and materials that are ejected from a volcano. The particles may be carried out for many miles before eventually falling to Earth, often causing great damage. Gas and dust also arise from the volcano and form clouds. These clouds can move across the sky for many, many miles as well, sometimes causing beautiful sunsets for thousands of miles around. That's our parts of the volcano work. Now, as you saw, I demonstrated a few experiments which depict some things that are happening in this stage of Earth's formation. The first activity, which you could do at your house, involves impact craters, which I demonstrated with a bowl full of flour and some various sized rocks. Some pebbles sized, some smaller than that, some larger. And you can vary your experiment by dropping the pebbles or whatever projectile from higher or lower and see what difference it makes. You can have ones that are small, such as this size. You can have others that are larger and see the difference that they make. Another one, which I did not demonstrate, is the properties of lava experiment. This demonstrates how lava can travel great distances, and it shows how it can travel while cooling and solidifying, and to see the different ways that that occurs. That experiment can be done using chocolate and marshmallows, so it's also a tasty experiment as well. As always, you're welcome to draw and label and define our parts of the volcano. And for those of you interested in that, I challenge you to recall our layers of the Earth, because volcanoes occur due to the layers of our Earth. Now, here in our core, we know our core is solid, and it's so hot, at times it can reach temperatures similar to the surface of the sun. And because this core is so hot, it can turn some of the solid rock in the mantle into liquid. It gets so hot it can melt rock, and that rock rises up to the surface, and where it finds a crack in the crust, that's where it will come up and out of the surface in a volcano. Sometimes that happens underneath the ocean floor, which I tried to demonstrate outside with some candle wax underneath some sand with water on top. And by heating it up, eventually that solid wax it became a liquid, and it made its way and eventually rose up. But as it went from a liquid, when it was really hot, it hit the cooler water and cooled down, becoming a solid once again. You kind of saw that process. If you want to see it more closely, I'll include a link for you to do that at home. But for our parts of the volcano, since it's intricately connected to our layers of the Earth, I would do a review of your layers of the Earth, and then up on the surface of the crust, you can draw your volcano. Then maybe put a square around it, and then draw an arrow someplace else where you're going to enlarge or magnify that square and draw an even larger parts of the volcano. That way you can show all of the intricate parts that you just learned about. Always a fun one. The Ring of Fire map is something very interesting that would involve a world map, something similar to this, and there's a place called the Ring of Fire. Can't really see it on here. This isn't the best map for it. Let me grab a different one. There's an area where there are so many volcanoes that are active, they've called it the Ring of Fire, and it is in the Pacific Ring. And so we have North America here, down to South America, down around through the Pacific Ocean, up through the eastern side of Asia. That's the Ring of Fire. If you are interested in volcanoes and you enjoy doing maps, you might want to make a Ring of Fire map. In this folder, there will be both a world map that's blank, as well as a control chart where you can get the information about the Ring of Fire. Maybe identify some of the most famous active volcanoes on the planet. Some of them are in the Ring of Fire. And then, as always, if you are interested in learning more about volcanoes, research is always a great option for you. Similar to the solar system, I have a printout with the time of the volcanoes. Has some great information in here. It will require at least a 3rd grade reading level. So if you're at those NPR books in our classroom, you probably could read this on your own. Chapter book and primary phonics readers, you probably would need a little assistance, but I'm sure your parents or older siblings would be happy to help. And when you're researching, I'll also include a few videos from National Geographic and Scholastic, which demonstrate some active volcanoes. It talks about volcanologists, or scientists who study volcanoes. And it also points out 3 very famous volcanoes. Mount Vesuvius in northern Italy, Mount Krakatoa in Indonesia, which is in southeastern Asia, and Mount St. Helens, which is up in the northwest corner of America. Now, all three of these active volcanoes have an interesting history that very drastically impacted the people living there. I'm not going to take any of the learning opportunities away from you, but if you like volcanoes and you enjoy research, choosing one of these three specific volcanoes to research could be very interesting for you. And as always, we don't want to just do the work. We want to engage with the work, learn something, learn many things, practice it until you've mastered it, and then the fun begins. That's when you get to decide, how am I going to show what I learned here? So, use your creativity, flex those creative juices and muscles. I know you have them. And choose one, two, heck, choose all of them if you really enjoy volcanoes. Watch this video again for the demonstrations. Obviously, you can make your own volcano at home. You might not have a model such as this, but you can very easily make one using clay or paper mache. You can also make one out of sand and dirt. I might recommend trying to do it that way because then it's going to look and feel more real, like a volcano you would see out in the world. If you are going to do one, definitely find a place where a mess isn't going to be an issue. And if you're going to build one outside, this is how I would recommend you do it. I would recommend you get a plastic bottle. Could be a 2-liter like this, or a 16 or 20 ounce one would also suffice, like a disposable water bottle. Now, in here, you can put baking soda. I would put a good amount of baking soda here in the bottom. And if you want your volcanic eruption to look like lava, what could you add to the baking soda that's going to make it look red, like my demonstration? Food coloring. All right, once you have those items in your plastic container, place it wherever you're going to build your volcano. If you're using sand and dirt, I'd recommend outside. Now, form that around it up to the crater. And remember, the crater is going to be a circular opening at the top. And you want to leave that opening at the top accessible. But build up around it. You'll have a beautiful volcano. It's one of the types of volcanoes. I'm not going to tell you which type it is. If you're curious, there's another research opportunity. Then, once you have your volcano prepared and you are ready, then you're going to use another simple home ingredient, vinegar, white vinegar, nothing special, and you're going to put it into the opening of the bottle. Now, pro tip, the faster you get the vinegar in there, the more explosive your reaction will be. So, if you are having a tough time pouring vinegar into this small opening, a large funnel can be helpful. But if you pour a large volume of vinegar into this, you know what's going to happen. So get out of the way, watch, and enjoy your volcanic eruption. All right? That's parts of the volcano. Sorry that it took a little bit longer to get to you. I had major technology difficulties this morning, but hopefully this all works now, and I hope you enjoyed your presentation.